Hi, this is my instructional design case summary based on a case called Establishing a Virtual Makerspace for an Online Graduate Course by Krista M. Rundix. The case overview will include a brief summary, main issues and design decisions, resources and context, instructional design approach and traditional learning theories applied, solutions, iteration and problems, evaluation, my interpretation of the case, and case reference. Two professors and one doctoral candidate from North Carolina State University set out to create an effective online makerspace for 6 graduate students and eventually for more online distance learners. A makerspace is a learning environment most typically conducted in a physical location, utilizing face-to-face communication, facilitated learner support, peer-to-peer collaboration, and real-time feedback. In a makerspace, learners have access to materials, tools, and guidance so they can design, create, and build projects that pertain to robotics, 3D printing, electrical engineering, computers, and coding. To launch this idea in 2016, the professors developed an online course for graduate students with an objective to teach those who will serve in technology leadership roles. The professors realized the need to provide an opportunity for distance learners who would not otherwise partake in a makerspace in person due to geographical constraints, lack of community resources, learner support, or other impending cultural restraints. The main issues that encompass this design problem are how to establish a virtual makerspace when these spaces and their supports are typically physically sited, and how can educators support makers in sharing their work and giving and receiving feedback in online environments. After 18 months of evaluating makerspace projects from other successful courses, the professors selected 6 projects pertaining to circuitry, robotics, and physical computing and fabrication. They felt these were best suited towards an online learning environment and also selected the best strategies for students to document their design processes. The 6 makerspace projects that were chosen could be easily packaged and mailed to students and were cost-effective when purchased in bulk and redistributed. The professors also applied for additional funding to offset any other costs outside of regular semester tuition. There was an additional $45.22 for a kit fee. The projects consisted of conductive poetry, an LED greeting card, a soft circuit wearable brooch, a spin bot or scribing machine, a computer program that reacts to external inputs, and a 3D design that would output to a printed object. The instructional design approaches used in this case consisted of scaffolding, which helped the learner build upon a level of difficulty, a constructionist approach to STEM learning, adult learning and self-directed learning, social cognitive constructivism, and socio-cultural approaches. Solutions for this case that helped facilitate an effective online learning environment included a learning management system, a wiki for students to share project information, a syllabus with guidelines for using technical software such as VoiceThread, which was a major technology component used to document student designs, Tinkercad, a software program to create 3D projects, Autodesk Project Ignite website, which provided step-by-step guides, and a potential use for Google Hangouts to do synchronous online meetings. After 2 iterations of this course, design changes were implemented. One included obtaining a mini grant to purchase a 3D printer so that students could see their final outcome. They also purchased a mini tripod so that they could capture time-lapse video of their 3D objects being printed. Materials were greatly culled down to reduce cost and waste. The class increased from 6 to 11 students, and the professors felt that they would like to incorporate 2 optional frameworks, these being engineering design thinking and computational thinking, so that they could help their students better reflect on their projects. Validation for the 6 projects in the class was done by a local College of Educational Computing and Technology committee. Critical incident analysis was used by the professors to identify scenarios where a problem was encountered and had to be resolved. This was done by creating multiple spreadsheets that recorded data on each student per project and then cross-referenced the data to find where students expressed similar difficulties. Through their evaluation, they found that students expressed difficulties in following the tutorials where steps were left out. Further effectiveness was also determined by students who attempted to make projects with their own children and teach their own makers class. I believe the professors did their due diligence in pre-evaluation of other Makerspace courses before implementing their own. They provided appropriate technology to students to facilitate an effective online class. They kept learner costs outside of tuition to a minimum and did an impeccable job using critical incident analysis in their evaluations. I agree with all of their modifications to the course, but would have implemented one synchronous group session per project earlier on or midway through to answer any incidents in real time that came up from students. Case conducted by Oliver K., Moore R., and Evans M., 2017. Case title, Establishing a Virtual Makerspace for an Online Graduate Course, a Design Case, found in the International Journal of Designs for Learning, Volume 8, Issue 1.